This is lesson 53, BHDL example 32, and in this example we'll design a 4-bit shifter. So we saw this one in the previous lesson, and we had 4 Ds coming in, and the outputs Y are various shifts of D depending upon the value of the 3 control lines S2, S1, S0. So to do this, we will write the entity in VHDL. D is 3 down to 0, this input. S is the 3 control lines, 2 down to 0. And Y is the output, 3 down to 0. So we implement it just using a big case statement. Process DS, so case S, when S is 0, there's no shift, so Y just gets D. When S is 1, we want to shift right. Well, to shift right, we put a 0 in the most significant bit and then concatenate it with D3 down to 1. So what used to be D2, because we put the 0 here, is the old D3. What used to be D1 is now the old D2, and so forth. So that just shifts it right. When S is 2, we want to shift left, so we'll put a 0 coming into the right, so we concatenate that with D2 down to 0. So now the new D3 is the old D2, you see, so it gets shifted left. When S is 3, we want to rotate right, so the only difference between shifting right, instead of putting a 0, we're going to bring D0 around. So D0 is the most significant bit that gets concatenated with D3 down to 1, just like shifting right. To rotate left, instead of the 0 here, we'll bring D3 around and then shift everything to the right, just like we did up here. The arithmetic shift right, you remember, keeps the sign bit the same, so we have D3 concatenated with D3 down to 1, just like we did for the shift right. Finally, this rotate 2, the new D3 is the old D1 down to 0, so we're shifting 2 bits, and then what used to be D1 down to 0 is the old D3 down to 2. And finally, the 7 we did no shift. Remember, we need others in the case statement. We'll just put a no shift there. So we can check it with a simulation, and we'll make D a B. That is a 1, 0, 1, 1 coming in. And here's Y for different values of S going from 0 to 7. So here's 0, no shift. If it's 1, we want to shift right 1. To shift right 1, here the Y3 gets shifted here, Y2 gets shifted here, Y1 gets shifted here, and we pump a 0 in here. So that's shifting right. Shifting left is when it's 2. Now this is the one we're shifting left, what's out here, so Y0 goes into Y1. We pump a 0 into the least significant Y0, and then this Y1 goes to here, and this 0 goes to here. And you can check the other ones out. Well, let's take a look at the arithmetic shift right. That's number 5. And remember, that should differ only from the shift right, and the 0 should be replaced with D3, keeping the sign bit the same. So here's what we start with. So on 5, arithmetic shift right, here is the sign bit, so that should stay the same, and you see that it does, and that's the only difference. Here it went to 0, we pumped a 0 in. Here it stays the same, and then everything gets shifted. This 1 gets shifted to here, this 0 gets shifted to here, and then this 1 gets shifted to here. So the 5, you end up with a 1, 1, 0, 1 for the arithmetic shift right, whereas for the logic shift right, the shift right, you ended up with a 0, 1, 1, 0. And you can check the other ones to see that they work.